Login accepted.
Hi everyone. So my name is Alon Kiriati. I'm from Devoxx, Tel Aviv. And I came all the way from Tel Aviv to here to talk with you about the one thing I am most passionate about, which is football. Anybody recognize this team? Any Scottish people here? Nah. So this is the Scottish national team. It's okay if you didn't recognize them. They're not the best team in the world. But the reason there's a picture here for the Scottish national team is because I really like to travel, and I also like football, as I said, and I really like to combine these two. So a few months ago in March, I was in Scotland, in Edinburgh, and I really want to go to see a game. And this team played in this game against Ukraine, and I wanted to see this game. I'm not Scottish, so I didn't know where can I buy tickets. But there's one tip I can give you. If you don't know something, there's a nice site called Google. I don't know if you heard about it. So if you need to search something, you put in Google, are there available tickets for the game? And Google still didn't give me the answer, but it did direct me to a site where I can find tickets. So I went to this site, pressed the button, the buy online. It's really easy to spot this button. I pressed the button and just redirected to another website where I can actually buy tickets. Well, I pressed this button, redirected to another website where I can actually select seat. At that point, I was really happy. I can actually select seat, and there are available tickets. But when I pressed that button, I was redirected again. No, wait a minute. You first need to register an account. Well, at that point, I thought, it's okay. I want to buy tickets. I'll just register a new account. And I was redirected again to fill a form. So far, it was quite easy, just like pressing the buttons, following this yellow brick road, but now I was giving a real task, just filling a form. It was an easy task. I know my name, I know my last name, I know my date of birth, so I could fill everything easily, just to be redirected again. And this time, I was given a hard task, a password. And not just a password, it has to have 8 to 64 characters long, contain 1 uppercase, 3 lowercase letters, 1 number, 1 special character. I had to read it twice until I understood what they want from me. I thought, well, I don't have any password in mind. I'll just get to this back later. And I never came back. So while I understand why security is important, this site actually lost a customer. But why am I here still talking with you about passwords? Like passwords is something from the past, right? From the 90s or something. Today we have so many new means of security, like fingerprint, face recognition, sign in with Google, sign with Facebook, sign with Spotify, sign in with whoever you want. Why are we still here talking about passwords? Well, apparently, all these sites, all these means of security or authentication together covers only 2% of the website in the internet. For 98% of the website in the internet, you can only sign in with password. And what's the biggest threat for security with passwords? It's data breaches. So today, there are more than 2.7 billion records of users in the darknet with tens of thousands of passwords. All in all, data breaches cost 2.1 trillion billions to companies. These are huge numbers. And I'm sure all of you work in companies and you hire the best expert that you can. But believe me, I know all these companies like Facebook, Microsoft, and they also hire the best experts. And if they suffered from data breach, I hope not, but it can also happen to you. And when it happened, again, I'm sure you have all the means of security, but when it happened and somebody can put their hand on your user's database with the hashed, obviously you all hash your password with salt and everything, but if somebody can reach all these hashed passwords, the only thing that can differentiate between a user that has been hacked and a user that is still safe is the strength of their password. Now, at this point, you can say, well, what's the problem, right? let's just require all our users to use very, very strong passwords. And let's also require them to use two-factor authentication and more means of security. But this comes with a cost, right? Because the more you add like more means of security, you also make your UX more complicated, and especially the sign-in flow. Just remember the last time I went, I tried to sign up to a site. I put all my details, the password, and the site told me, okay, this password is not strong enough. So I put a stronger password, and then I got a link to my email. I needed to go to open a browser, went to my email, pressed the link, and then it told me, okay, now we send you an SMS. And the phone was in the other room. I was really frustrated with all this process just to sign up to know. I didn't even know what this site do. So this comes with a cost. On the other hand, you don't want to compromise on security like totally. You do want your site to have some security. So you try to find the balance between these two. And the balance can be found in advising the user instead of forcing them to do adding more means of security, just advising them and pushing them to add more means of security. But whatever you want to do, and that depends on your data sensitivity, you want to stay somewhere between the advise and require. And you don't want to compromise security. You still want to have some security. And it depends, again, on your data sensitivity and how secure you want to be. You can think about more creative solutions. For example, maybe some of the features only blocks them for users who have 2FA or stronger password, or maybe just let the users start using maybe weak means of security and then try to push them to use more means of security. So what do you want to do now is, let's say you have your website and you want to add more tools for security. So this is an example from Facebook where they have a very long list of security features, and let's say you do want to build like all these features or some of them. So where do you start? Well, you can build there are many features for security. I kind of looked on the most popular sites today, found out what the most popular security tools, and just the list, the first thing that most of the popular sites will build is logins. For example, password estimation, two-factor authentication, also integrations with Google Sign-On, SSO, Facebook Sign-On, and so on. So everything around logins. The second area you probably want to cover, if you don't have any security or any security tools, is device or web control. Show the user their connected devices, show them their up and web sessions, and let them disconnect from all these web sessions. Another area you probably want to cover is recovery. What happens if the user lost their password or lost any access to their data? So recovery mail, recovery codes, everything around this. And some more optional features that most of the site has are around session control, idle time, how much time the user can be idle, how much time they can be signed in until they need to sign in again, alerts, if you can give them some alerts about suspicious activity or new sign-ins, and also everything around their data. If it's third-party app that they're using, or even encryption, if you want to give them encryption for their data, or define keys, and so on. So these are kind of like lists. You can also add more and more features for security. This is kind of a list I try to compose from the most popular sites today. And I think but the most important thing, if you're not sure what you want to build, is try to build features that are more contextual to your site. So I know it's a little small, but this is a list from Zoom. And just like try to read, like this is a feature that they have. And if you look in the keywords, you'll see meetings, rooms, passcodes, conferences. You see that most of the feature here are contextual to Zoom. It's not like general features as you saw before, but also features that are in the context of your product. So it's important to build the basic features, but also features for your specific cases. After we finish building these features, we need to set enforcement level, understand how much we want to enforce these features. So just an example, password strength. For example, this is from Amazon. You can put the password there, and Amazon won't tell you if the password is weak or strong or anything. It just lets you sign in. Maybe a better solution or a stronger solution is advising the user. At least tell them some details about the password strength. Tell them if it's weak, if it's strong, and what they need to do to make it stronger. And even a stronger one is enforcing the user. Not just letting them and hinting them about their security, but also enforcing them to use strong password. So you can see here 3 sites with 3 different enforcement levels. Another example I can give is from Google. So for example, in Google, you can sign in without having 2-factor authentication. Right? You can sign into Google with only a password. But if you want to be a developer and you want to also, for example, what you want to upload Chrome extensions, then Google will enforce you to use 2-factor authentication. For some of their features, instead of the features, they want to enforce you using 2-factor authentication. So we talked about enforce. And for the features that you don't enforce, encourage your users. If you just build features, hiding in them some settings pages, some security pages, users don't care about security, according to research. They really don't care about security, maybe only the advanced users. So it's also important to encourage users, building them tools. For example, this is from Dropbox. It's a security checkbox that we have. So there are 6 simple steps that the user can take. And we send users emails and notifications. They don't need to go to all the menus and try to find features. We're telling them, this is 6 steps you need to do to improve the security of your account. This is another example from Google. Maybe if you have Androids, you might have seen it. Sometimes Google will prompt you to increase your security, tell you what you can do better. And another example is also from Facebook. They're building tools, sending emails and notifications to make sure that their users will do very simple steps to increase the security, not only for advanced users. So we talked about build, we talked about enforcement level and encourage, and the first step you can take is delegate. So this is for B2B, business-to-business products. So if you want, for example, we're Dropbox, we have, I don't know if you know Dropbox, but we have a tool that can let users sync file and collaborate with each other. But we also have our B2B product, so teams, organization, companies can buy Dropbox for their organization. And each team that buy Dropbox, they also have an admin. And these admins configure the settings for their users, for their organization. And we want to move the more control to admins, right? We at Dropbox, we do have some enforcement level and some security, but these admins want to have like different security levels for their users. For example, if we talked about 2FA at Dropbox, we don't enforce our users to use 2-factor authentication, but some admins want to enforce their team to use 2-factor authentication. So we let them do that. We also let them define how many devices can connect to Dropbox, and also giving them more session control. For example, in Dropbox, you can connect to Dropbox and stay idle as much as you want, but some admins want to set the idle timeout for their users. So we delegate all these decisions to the admins. Now, admins came us a few months ago and told us, OK, we also want to set the requirements for the passwords for our users. In Dropbox, we let users connect or sign up with any password more than 6 letters, but admins wanted more than that. They looked at what our competitors has, and they have this panel for admins. So admins, in our competitors' admin console, they can configure the minimum required characters for the password. They can also configure if a password for the users must require a number and then the number of numbers. Then require special characters, yes or no, and then the number of special characters, and uppercase and lowercase. Like there are many, as you can see here, there are many checkboxes and many drop-downs, so admins need to make a lot of decisions. At Dropbox, we do things much simpler. So we thought, can we build this, but much simpler? And I think the way, if you want to build simple or good UX features, is to first understand the problem you're trying to solve. And a way you can do this is by asking the 5 whys. 5 whys, if you're not familiar with it, it's a technique started, like many things, started in Japan in the car manufacturing pipelines. So in Japan, in the car manufacturing, if there was a defect in the pipeline, the manager will go to the employee for the employee and ask them 5 times why until they understand the root cause. Why did it happen? Why did it happen? Why that happened? Until you can really understand the root cause. So we can also use this in the product world when you want to understand the user and you want to understand their problem. Not the solution, but the problem they have. So this is what we did at Dropbox. So our users came to us, the admins, and asked us, Dropbox, I want to have the same password control as your competitors. And we're, okay, you want that, but why? So they said, well, obviously, I want to force my users to use long password with special characters, number, and so on. Oh, you want this? Why do you want this? And they continue. So I want more control over my users' passwords. Oh, you want more control over your users' password? Why do you want that? Well, I want them to use a strong password. Oh, we're getting you better now. We understand you better. You want your users to use strong password. Why do you want that? So I want to reduce the risk of account hijacking. And then the last why, before they break, why do we want that? Why do we want all this? Well, then you get the problem that they really have. They want to keep their team file safe by enforcing them to use a strong password. That's a problem that they have. So if you want to solve this problem, we first need to understand what a strong password is. I put here 2 passwords. The first one is Troubadour &3 with a few tweaks. And the second one is Blue Giraffe Plays Ball. Now let's make a short poll, raising your hand. Who think the Troubadour is a better password? Nice. Who thinks the Blue Giraffe Plays Ball is a better password? Okay, something like 50-50. So I don't know. I have no idea. But I gave you the tip before. When I don't know something, I go to Google. So Google, what's considered to be a good password? And the answer I got from Google is, well, a good passwords need to have 4 elements. It has to have 6 characters or more, mixed cases of upper and lower case, numbers, and special characters. Okay, so let's take all these elements and put this password into a table and see which password is better. So you can see that Troubadour has all these elements, while Blue Giraffe Plays Ball, not so much. So it's easy to call the winner here. Good work for the one who voted for Troubadour. Really impressive. But after I saw this and I went to sleep, I recall a story I really liked as a kid. It's called Alibaba. And in Alibaba, not this Alibaba, this Alibaba. In Alibaba, you have this very famous password, Open Sesame. Now, Open Sesame doesn't have any special characters, uppercase, lowercase, numbers. It was invented long before somebody can even think about it. So there must be a better definition for a good password. And what do you do when you don't find the answer in Google? You go to comic books. So there are very comics site that I like, XKCD. And actually, there's a better definition there for a good password. A good password must have 2 elements. It has to be hard to guess, but then easy to remember. That's all you need for a good password. So let's check again these 2 passwords with only these 2 elements. Hard to guess, it's the number of guesses required to crack a password. So what's the naive estimation? The number of guesses is the cardinality in the power of the length. Spooky math. Now, let's do an example. It will be much clearer. So the cardinality is the number of options that you have for a single character. If you only use lowercase characters, you have 26 options. If you also use uppercase characters, number, and special characters, you have 95 options for a single character. So the number of guesses is required for just random lowercase letters is 26 to the power of 6. 26 for the first letter, 26 to the second letter, and so on. So 26 multiplied by 26 multiplied by 26, 26 to the power of 6. If you also use uppercase numbers and so on, it will be 95 to the power of 6. And in the rate of 1,000 guesses per second, you'll see that the first password can be cracked in 15 days only. It's a very weak password. The second one, it will take you 140 years. That's a lot of time. And this password is actually not crackable. So now you understand where all these rules came from, right? The longer the password is, the more cardinality you use, the harder the password will be to guess. But we're humans, right? We're not robots. So I can tell you, for me, personally, to just remember 8 random characters with uppercase, lowercase, special character, it's almost impossible. And I guess I'm not the only one here in the room that it will be hard to remember these passwords. So what users do, many users do, is using templates, patterns. So for example, in this example, we took the troubadour. It's a word in English, an uncommon word, one that you can find in a dictionary size of 2 to the power of 16. Then we're doing some tweaks. So the obvious tweak is just uppercase or lowercase the first letter. So there are 2 options. Then the other tweak is what we call lit. So lit, if you're not familiar, lit language is just a set of transformations, visual transformations, where you take an O, turn it into a 0, 4 to A, 3 to E. It's a very short set of rules. People think it's a very sophisticated thing to do, but actually, computers can predict it very easy. It's just like a very short list of rules. And there's only 2 options for each one. Either it's an O or 0. So we have here 3 letters that can be lit. Then it's 2 to the power of 3 options. Then a special character, you have like 16 special characters, 9 digits, and the order within them is 2. So if we sum all this up, we'll find out that this password can be cracked in 2 to the power of 28, only 3 days. So this password is easy to guess. What about the second one, the blue giraffe plays ball? Well, you have 4 words here. Each one is pretty common in English, so it's a shorter dictionary. One you can see 2 to the power of 11. And when you sum all the 4 words together, you get up that this password can only be cracked in 2 to the power of 44 guesses. It will take you 540 years in this rate to crack it. Now, I don't know about you. I don't think I'll live so long. So this password is much harder to guess, actually. And which one is easier to remember? Yeah, obviously, the trombone (3), or was it it's a troubadour? And which letters did I lead? First O, the second O. I don't know. And there was like a number, and who knows, right? I've done this talk like so many times before, and I'm honestly, I have no idea what's the original password. It's maybe one of these, maybe not. Who knows? What about the other one? Yeah, I know. Blue giraffe plays ball. We always say blue giraffe plays ball. Cool. So now we know which password is actually better in a more realistic way. Let's take another example. Password 123456 exclamation mark. Now let's break it into the parts. Password, the first word in any dictionary, any cracked password dictionary. 123456, the second one. So we need 1 guess for the first, 2 guesses for the second, and then 16 guesses for the special character there. Now you probably don't need to make all these calculations. You can see that this password is really weak, but if you want to make the calculation, it will take you seconds to crack this password. So let's do a challenge. Let's put this password in probably the most popular sites today and see what they think about this password. Well, I first put it in Gmail, and Gmail told me this is a very strong password, full bar. Whoa, amazing password, right? I thought maybe Facebook is better in password estimation, and no. They told me also this is a strong password. Twitter, maybe no. Also Twitter, this is a strong password, full bar. Maybe Apple is doing a better job. I don't know, they do things different. Well, no. Also in Apple, this is a very strong password. And also Apple give me the reason, thank you. So this is not only bad, but it can be actually mislead users to use weak password. and have security issues. What if we have a better tool, something that can actually do the thing that we did before, a realistic estimation of password, break it into the parts, and give each part its entropy, its number of guesses that needed? Well, we do have one. It's called ZXZVBN. It's just like the letters, it's like QWERTY, but the bottom side of your keyboard. It's ZXZVBN, it's hard to say. It was built in Dropbox by Dan Wheeler 10 years ago in what we call Hack Week. It's an extended hackathon that we have every year. It's open source under MIT, so you can actually use it or do whatever you want with that. And it has more than 10K stars. It's probably I think it's the most popular password estimation today. So how to use it? Really simple. npm install node require and run the ZXVPN with a password. That's all you need. This is for JavaScript. The only thing you need is import and use. That's all you need, actually. And it's also supported in other languages. I just gave you an example from JavaScript, but it's supported in Python, Java, Golang, whatever like crazy languages that you want. It's supported in most of the popular languages today. It's really fast, actually. It takes 5 to 20 milliseconds to work to estimate a password, up to 25 characters, and it's very lightweight, less than 50 kilobytes for the actual code, and then 1 megabyte for the data, the dictionaries, and so on. So how does it work? This will be like a tech part. I'm not sure if everyone is here at tech part, so like algorithms and code and so on. So feel free, like if you want to listen, if not, just like take a nap or something. It's going to take like 7 to 10 minutes. I'm going to wake you up. So I think it's really nice. It's a little off topic, but I think it's really interesting to see how this algorithm actually works and how it's so efficient. It takes so like very fast. So let's see. This algorithm is composed of three steps. The first one is match, then score, then search. So in the match step, we want to take all the substrings, all the possible substrings. For example, password 1, 2, 3, 4, 5, 6 is a substring. Password is a substring, 1, 2, 3. So we're taking all the possible substrings. We break it to all the possible substrings. Then we want to match each substring. So we have 8 matchers. The first one, we try to find it in dictionaries. It's the TV and movies, English names, and just we have like a set of dictionaries, cracked passwords, and so on. The second matcher is reverse. We're just reversing the password and checking if we can match it with anything. Then lit, we talked about we do the lit modification and see if we match it with anything. Then spatial, like queries, ZXVPN, all the keyboards that are next to each other in the keyboard. Then repeating, if AAA, 112211, for example. Dates are also very popular in passwords, so we try to find like patterns in dates. Sorry, date patterns in passwords. Sequences like 1, 2, 3, ABC, and so on. And if we don't find anything, we just like brute force, and this is just like random letters and numbers. So for each password, we try to match it with the matchers. And in my example, for example, you can see that password is a word from the dictionary. 1, 2, 3 is a sequence, and 1, 2, 3, 4, 5, 6, it's also a sequence and also a word in the dictionary. So we take both. So you can remove all the others, the one that we didn't find any matches. Those will be like brute force. And we're taking all these to the second part, which is scoring. And for example, in the dictionary, if we want, the rank is the number of the password where it finds. If it's like the 2nd word or the 20th word, we take this rank and we log it. Then we reverse it +1. And more complicated calculations for the next one. I won't get to each one of them. I can, if you want, you can come after this talk and talk with me with each one. We have like a calculation for each matcher. So we score each match. For this example, password is the first one, so it's 0, it's a log of 1. Sequence, we give numbers, we give score for every match that we found. And we take the minimal one. For example, 1, 2, 3, 4, 5, 6, we take the minimal one, which is a dictionary. So what we want to do next is searching, right? We have a lot of substrings. For each one, we have a score. We want to find which one is better. Is it password 1, 2, 3, 4, 5, 6, which is only brute force? Is it password, then 1, 2, 3, then 4, 5, 6? Or is it password? We want to find which is the solution that gives the minimal score. In this example, for example, the minimal score is password, 1, 2, 3, 4, 5, 6, and exclamation mark, broken to this part. We want to see what's the best way to break the password. Here we're removing this, and we want this to be the winner. Now we can do this like in a brute force way, just like taking all the substrings and calculate them together. Sorry. But we can see here, for example, you can see the 1, 2, 3, 4, 5, 6 repeats again and again in many solutions. So this can hint you that you can use here a more efficient solution, which is dynamic programming. Let's skip this one. So we put all the solutions into a table. Then in the columns, you can see the index. We have the password 1, 2, 3, 4, 5, 6, and this index. And then each time in the rows, we're adding another substring from where it starts and the score. Then again, we won't have time to fill all this table. It may be fast, so you can come to me after this, and I'll show you how it actually works. We're filling this table with a scoring, and at the end, you can see here, we get the minimal score, which is 3, and we can backtrack to see the solution. Cool. So that's all. If you didn't listen to the technical part, we're getting back to our issue. So BURR, if you don't want to listen to me, if I'm not an expert here, BURR is an expert. He came up with all these rules in 2003. He thought all these rules are amazing. And a few years ago, he said that he regrets all these rules. This was a huge mistake because he also saw these patterns. And after his recommendation, also, the NIST, the National Institute of Standards and Technology, updated their recommendation for passwords. I don't know if you saw it, but one of the things they said, no more password hints. Users many times just like put their password in the password hint or giving too much information. Also, no more knowledge-based authentication. This is not anymore recommended. Asking users some personal questions, like what's the first name of your pet, your first school, what did you have for breakfast? I know all these questions are not relevant anymore. They're not helping. Also, no more expiration without a reason. Another thing that users do is whenever they ask to refresh the password every few months, they just have a counter in the end and just an increasing the counter or something like that. Also using patterns, so it wasn't helpful actually. And more relevant to this talk, no composition rules. All these rules that we saw at the beginning are not recommended anymore. So now that we understand what's a strong password, let's get back to our problem, right? Our admins want us to build them a tool that will help them give them more control over the user password. So instead of building all these checkboxes, numbers, dropdowns, all these, we build them that. Only one dropdown. So we ask them the question, do you want to require your team to use a strong password? There are 3 options: no, strong, and very strong. That's all you need. That's all they care about, right? They only care about, they want to require the user to use a strong password. They don't care about all these checkboxes and dropdowns. And apparently, this was a win-win-win situation. It was very fast to build that. You can see, like, comparing to the other, it was easy to designers that didn't think about all the checkboxes, how to put checkboxes and dropdowns and all these in one screen. It was easy to product because they don't need to think about all the edge cases, and there are many edge cases. What if the user has like more than 10 characters, but many special characters? They want to add more special characters, want to remove, do we need to, like so many like edge cases you can think about. And it was easy for the most important thing, it was easy for us engineers. We just need to call, we don't need to do all the checks, we just need to call the algorithm, get the solution back, that's all. It was also a win for our users, for our admins, because this is a very simple solution for them. They don't need to make a lot of decisions and read a lot of checkboxes and dropdowns. Take only one decision. It's very clear what the decision should be. And it was a win to our end users because they have a much stronger password estimator, so we can actually increase the security. So we built a tool that is both good in UX, but also increases security. Cool. So let's now wrap it all up. That's all. Let's get to the conclusion. So what did we talk today? We started with finding the balance between UX and security. We talked about building features. Remember, building basic features, and then add more security features that are relevant with the context of your features. Then also deciding what to do, the enforcement level, how much of the features you want to enforce. And make this deliberate. Just don't drop to any default. Make sure you talk with your product designers, product managers about this. Make it very clear what's the decision. Then encourage users, the one that you don't enforce, encourage users to use these features. And at the end, if you're working in the B2B industry, also delegate build features for these admins or for these teams that they can configure the settings for their team. Then we talked about one specific use case. We talked about password estimation. We first started with why you should even care. And then we talked about what you can actually do. And then the how, we talked about what's a good password. Remember 2 rules. It's have to be hard to guess, but easy to remember. Then how do you actually estimate a password? So we saw how you can do it manually by thinking about all the patterns. But again, you have this tool. You can just use it probably faster. But what can we learn from this specific use case for UX and usability? How we can build features that are both usable and have a good security. So the first thing we learned, don't build everything automatically just because your users ask you to. Many times the users just copy from others, look at their competitors. They can think, maybe they think about solutions. You should think about the problem. You should understand what problem they have, understanding the root cause of their problem. You can do this by asking the 5 whys to drill down and understand what they actually want to solve. Then when you understand the problem, you can come with smart algorithms and smart solutions. We saw here an example for a smart solution that uses dynamic programming. You can also think about more solutions like this that uses machine learning to make things much faster and much easier and much secured. Also using some APIs to maybe grab some data instead of letting the users to put all this data. So there are more smart solutions you can think about it as an engineer. Because product and designers, sometimes they don't know, they couldn't, for example, come up with an algorithm like ZXCBN. This is why it's so important to work all together, product, designers, engineers, for the very first steps of a feature. Are there any engineers here? Raise your hand. Engineers. Oh, almost everyone. Cool. So one tip I can give you as an engineer is really don't be these code monkeys. John, and I'm not sure if you're familiar with that. John's get tasks from your Jira and do whatever you're told to do. Really question the tasks that you get. Understand what you're trying to solve if you can, and if your company allow you to. Also talk with customers, or really try to get in the first steps, understanding what you're actually building and what's the problem that your customers has. Any product managers, designers? No one. One? I'll talk with you. Half. Okay, I'll talk with you. No, actually, but if you're an engineer, also tell your product managers that they should involve you, add you to the first meetings about the problems that they have with customers or with designers. Try to be involved, really. Tell them that they should involve you, add you to the loop, because as you can see here in this example, sometimes only technical people can come up with the solutions that are good. So I think the most important lesson is only if we work together, again, program managers, designers, engineers, researchers, from the very first steps of a product, we can build features that are both secured but also have a good usability. That's all. Thank you very much. Thanks XKCD for inspiring this talk. Thank you, Dan Wheeler, who built this solution. And thank all of you. That's me. If you want to add me, ask any question. I'll stay here now and I'll also stay around the conference if you want to ask me any questions. This is my LinkedIn. You can also add me for feedback or any questions. And before you go, everyone, we are hiring. We're looking like Dropbox started to hire in Poland. We are all remote. So either you live in Krakow or Warsaw or whatever you want, really come join with us and help solving problems for hundreds of millions of users. We have a very good culture and a very competitive compensation package. So really, if you have also any questions about Dropbox or if you want to join, come talk with me. This is the page of the jobs. You can see we have like many jobs, infra, product, engineers, everything. Thank you very much.